I want to work through the solutions for your first vector practice problems. There are 7 of them, and we're going to go through them kind of one by one. For 1 hour, you travel east in your car covering 100 kilometers. Then you travel south 100 kilometers in 2 hours. You would tell your friend that your average speed was, and then you have an option of A, B, C, D, or E. Alright, well the first thing that we want to take a look at is we want to take a look at what we're looking for. We want average speed. Alright, and speed is distance over time. Alright, so in this case we're looking at simple scalar addition because speed is a scalar quantity. Alright, so direction doesn't really matter. All that we want to figure out is that we traveled 100 kilometers and then we traveled 100 kilometers. So the total distance would be 200 kilometers. Alright, and the total time, we traveled for 1 hour and then we traveled for 2 hours. So the total time would be 3 hours. Alright, so that means that solving for your average speed would be a simple problem of solving for 200 kilometers divided by 3 hours, or 66.67. Round that to 2 significant figures, and we've got 67 kilometers per hour. And so this is exactly what the lecture walks you through when we talk about simple arithmetic with scalar quantities. Everything is on the up and up. We just add them together, and we do our calculations with them as we'd expect. Taking a look at the same problem, for 1 hour you travel east in your car covering 100 kilometers, then you travel 100 kilometers in 2 hours south. You would tell your friend that your average velocity was, alright, now, velocity in this case is a vector quantity. Alright, and in vector quantities, the direction matters. So here, if we set our compass to north, south, east, west, then we have 100 kilometers east and 100 kilometers south. Alright, and so now this is a vector problem, and so we want to add our vectors by their components, and we would have a resultant vector, right? Your result displacement, right? Because velocity is given by displacement over time. Alright, so now we have to find our displacement. Alright, so we can use Pythagorean's theorem here, where our resultant velocity, which will be our average velocity, is going to be equal to the square root of 100 kilometers squared plus 100 kilometers squared. Alright, so that's going to be 100 squared plus 100 squared, square root of that. Alright, so we have 141.4 kilometers as our resultant vector. And the time did not change. It's still 1 hour and then 2 hours. So our displacement is going to be 141.4 kilometers over 3 hours. Alright, and then we have 47 kilometers per hour, where we don't cut off our significant figures at the end until we've come to our final answer. So we had to find the vector displacement using our vector addition technique to do this problem. So let's look. In this case, we have more than one vector, or more than 2 vectors to add together. You've already traveled east in your car 100 kilometers in 1 hour, and then south 100 kilometers in 2 hours. To get back home, you then drive west 100 kilometers for 3 hours, and then you go north 100 kilometers in 4 hours. You would say your average velocity for the total trip was, and again, we look at what we're finding. We're finding a vector quantity, which means that we're going to be finding the displacement over time. And I'm going to go ahead and I'm going to break this down by component. I'm going to take a look at all of the x components and all of the y components. You don't have to do that. If you take a look at this diagram, if you assume everything here is to scale, right? We had 100 kilometers east, and then we had 100 kilometers south, and then we had 100 kilometers west and 100 kilometers north. One of the things that we can see is that for certain, alright, if this was our start, it's also our stop. So visually we can see in this diagram that our displacement is 0. But I'm also going to show you how breaking this down into the x and the y components, and remember when you do that, you set your axis. So I'm going to say that straight up and down is y, and that completely horizontal is x. So now if I looked at all of the vector components in the x direction, I know that I would have 100 kilometers east. I would set that to be a positive value, so I have positive 100 kilometers from this vector, vector number 1. And then I have, for this vector number 2, I have 0 kilometers in the x direction. And then for this one, I have 100 kilometers west. I'm going to set that to be a negative direction because it's opposite of my original one. And then if I also take a look heading up here, this one, so that's vector number 3, and here's vector number 4, which has no x. Alright, so all of my vectors in the x direction would be positive 100 and negative 100. That'd be 0 kilometers in the x direction. And then I can do the same for my vectors in the y direction. Vector number 1 has no y component, so it's going to be 0. Vector number 2 is 100 kilometers, and south, I'm going to set south to be negative, so negative 100 kilometers. Vector number 3 is only in the x direction, so that's 0. And vector number 4 is going north or up, so I'm going to set that to positive 100 kilometers. And when I add those up, all of the vectors in the y direction equal 0 kilometers. And then if I find the resultant vector, square root of 0 squared plus 0 squared equals 0. So I know that because displacement is 0, it doesn't matter that it took me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hours. Alright, my velocity was 0 kilometers per hour because I was not displaced. So it was none of these. Alright, and then taking a look at number 4, you fly east in an airplane for 100 kilometers. You then turn left 60 degrees and travel 200 kilometers. How far east of the starting point are you approximately? Alright, so paying careful attention, we want to know how far east of the starting point. If this is the starting point and this is the ending point, then we know that we have traveled not just east, but we've also traveled north. Alright, so if we set an axis for this, I would, to be simple, since we're getting asked specifically about how far east of start, I'm going to set my x-axis to be straight east-west and my y-axis to be straight north-south. In this case, I could take a look, just focusing on my displacement in the eastward direction. One thing that I know is that first I traveled for 100 kilometers. Right, so my first vector in the x direction is just my displacement number 1, but I also traveled this amount right here, right, and I'll call that the x component of my vector number 2. Alright, so if I'm going to find out how far east I went, I'm going to be interested in the x component of my second motion. Alright, I also did go north, right? That would be the y component of my second vector, where this is my second vector. But I'm not interested in the y direction to find out my displacement east of the starting point. All I need is this section right here. So that means that in order to find this component, I need to use this ratio because I've been given this angle right here. And I know that if I'm looking at the side that's adjacent to this angle, then I'd be looking at the ratio of cosine theta would equal the x component of that second vector over the hypotenuse. All right, and remember, I'm interested in that x component, so I would solve this equation for that component. And it turns out that the x component of that vector is going to be that vector times the cosine of that angle. All right, so that vector times the cosine of that angle means that dx2 is going to equal d2, which was 200 kilometers that they traveled. So that's going to be 200 kilometers, the value of that vector, times cosine of 60, and that will give me the x component. That will give me that value right there. So I solve for it. So the x component of that vector was 100 kilometers. Right? That's what that equals. So now if I want to find my east of the starting point, I would just add d1 and the x component of d2. So that means that my total in the x direction is going to equal 100 kilometers, which is the first vector, which was only in the x direction, plus 100 kilometers, which is my x component of that vector, and I get 200 kilometers east of the starting point. All right, let's take a look at number 5, which we're still looking at the same situation. All right, we're going to fly east in an airplane for 100 kilometers, so we'll say our displacement vector 1 is 100 kilometers. We turn left 60 degrees, and we fly for 200 kilometers. All right, how far north of the starting point are you? So now we're using the same axis where east-west is our x and north-south is our y, and we're only interested in this value right here, how far north of the starting point. Because yeah, sure, it's north and east, but we're only interested in how far north we are. So we're only interested in the y component of vector 2. There is no y component of vector 1, so that means our total answer will be given to us by the y component of the second vector. So knowing what we know from before, right, we can use a ratio. In this ratio, the opposite of the angle is the sine of that angle. Will give us the y component of that vector divided by that vector, right, which d2, and solving this for dy2, dy2 is going to equal d2 sine theta. So that's going to be 200 kilometers times the sine of 60. Solving, it's 173 kilometers. So rounding to two significant figures, we can see easily that C is our answer. So one of the things that this type of work tells you is you want to take a look at what you're actually solving for. There's so much we could solve all at once for all of these components, but we're just focusing on which piece we can solve and what information we need to solve that. Moving forward with this example, alright, you fly east in an airplane for 100 kilometers. You then turn left 60 degrees and fly 200 kilometers. How far from the starting point are you, approximately? Well, now we're not just finding how far east or how far north, we're finding how far total. Right? And that means that we are trying to find what happens when you are displaced first 100, displacement vector number 1, 100 kilometers east, and then displacement vector number 2, 200 kilometers 60 degrees north of east. So that means that we're going to be looking for, that's right, this resultant vector. And the easiest way to find this resultant vector would be to find the components of this resultant vector. And the components of this resultant vector would be everything that occurred in the x direction, the resultant vector in the x direction, and everything that happened in the y direction. So that means we want to break it down. First, we want to find everything that happened in the x direction. Alright, so that means that we would be looking at the x component of vector 1 and the x component of vector 2. Right, that's d2x, that's this portion right here. And everything that happened in the y direction, which would be, for the sake of this problem, I'll say d1y plus d2y. Alright, so taking a look at that, adding up the x components should be d1x, that's all of this, that's 100 kilometers, because vector number 1 only happened in the x direction. Plus, we want the x component of d2 vector. So we're going to use that ratio again, and I'll write it out again. Remember, we're looking for x, which is the adjacent side. So cosine of that angle would be d2x over d2. Solve for dx, and I get that it equals d2 cosine theta. Solving that would be 200 kilometers times cosine of 60 degrees. And then everything in the y direction, right, d1y, there is nothing, so that'd be 0 plus, and then we'd be looking for the y component of the second vector, so that would be d2y over d2 equals the sine of that angle. So that means that d2y is going to equal d2 sine of that angle. That will be 200 kilometers times the sine of 60 degrees. And then we get that that equals 200 kilometers, and this one equals 173 kilometers. And you're going to notice that these are just the answers for the total displacement east and the total displacement north. Right, the total displacement in the x direction, the total displacement in the y direction. And now we can find our resultant vector, the result of having traveled this total distance in the x direction and this total distance in the y direction. And we're going to use Pythagorean's theorem for that. So the resultant vector is going to equal square root of 200 kilometers squared plus 173 kilometers squared. And I got that the resultant vector is 264 kilometers. Alright, and we'll go ahead and we'll allow the screen to clean itself up a little bit. There you go. And that more closely matches with two significant figures. C, 260 kilometers. And that's the magnitude of your resultant vector. But we don't know what the direction was. And so we can actually take a look at what that direction was. And I think, yep, what do you know? That's problem number 7. You fly east in an airplane. What direction are you from the starting point? Well, we know now that our resultant vector, dr, is a result of having traveled in the x direction first 100 kilometers straight east, and then the x component of the second vector, and also for having traveled in the y direction. Right, and this is 100 kilometers, and this was 200 kilometers, and so we know, right, that if we're going to find the direction, we need to find the relationship between the total distance traveled in the x direction and the total distance traveled in the y direction. And that relationship is given by the tangent of theta, which is opposite over everything in the y direction over everything in the x direction. So that's going to be 173 kilometers over 200 kilometers. All right, and we want to take the inverse of that. To get us theta. 173 divided by 200. Inverse tangent of that. It should be 40.86 degrees. Round that to correct significant figures, and we'd have it approximately 41 degrees. All right, and that direction is going to be that 41 degrees was north of east, D. Alright, and we can actually give it that value because we know that that's the direction that that displacement happened in. That's our total displacement vector. Alright, so this gives you a really quick and brief overview of vector addition. It's only going to get more complex from here, but this kind of gives you an idea of how to break it down. So make sure that you're comfortable with these, and if you're not, please make sure to come in and get a little bit of extra help.